Welcome to the second part of the tutorial on how to get the AVR framework work on the Oculus Quest. Basically, what we did in the first tutorial was the part necessary for the framework, and now everything that follows is just basic Unreal to Quest or to Android building. So a lot of it is just performance tweaking, because you really need to make sure your application runs in 72 frames per second. Actually, there is this great AVR metrics tool. It's from Oculus itself, and you can download it and put it on your Quest, and then you can make an overlay on all applications and really see where your performance is dropping. And that is really a great tool to debug your application if you don't hit the 72 benchmark. Okay. Let's get started with the project settings. The first thing we want to make sure is that we start in VR, obviously. Then let's go into our plugin folder and make sure the Oculus plugin is enabled. Oculus VR, you need this one here. Make sure that this is enabled. If not, enable it and restart your editor. And if this is enabled, you can go into your project settings, scroll down all the way to the bottom, and here's the Oculus VR plugin folder. And they have a really nice Oculus utility window. Basically, this goes through your project and really helps you to set all the settings according to the platform you're building. So in this case, we select mobile here, and there are a lot of things already in there. So multi-view, this is very important. It's like instant stereo, but for Android. So this is really important one. Mobile HDR. Well, mobile HDR, most of the time you are better off disabling this, because this is really expensive. It's that you have things like the bloom effect in the Quest, and while this looks beautiful, it's a very expensive feature, so maybe you need to turn this off. So let's turn it off. We can turn it back on later if we have enough performance. We need to configure our Android manifest, so let's do this. And we need to configure our Android packaging. There's things like full screen immersive. All the settings you had to do by hand in previous versions, you can do with one click here. Also, it says that there are some dynamic lights in there, and dynamic lights are really, really expensive. So we can select them. Okay, it's our directional light. It's set to move stationary. And of course, this is expensive. We don't really need to have it stationary. So let's set it to static. And we need to build our lighting later on. But in most cases, you want to work with build lighting. So this is totally fine. And there's another one in there. Let's select it. It's the light bulb itself. Okay, if we want to use this, this would need to be dynamic because it's movable. And we triggered it if we put it onto our battery here. So in this case, we really need the dynamic light, but this is only turned on once we connect both of them and the trigger's triggered. So this is not too bad. We can, let's see, all of them are set to stationary. Let's set them all to static. And these are already set to static, so this is fine. I also noticed that here, if we go into our shader complexity in quad view, you can see there are spheres around it with a volumetric material, and this is of course very expensive. You're not really able to spot a difference, at least not in VR. So I would go in there, delete all these spheres, check that this is correctly set up. There are a lot of reflection captures in here, so maybe we would need to reduce them. I guess we should reduce them, but we can also go into our project settings. Let's see, reflection capture resolution. Let's really crank this down. And maybe this way we will get away with using so many of them. Be okay. Also, one thing that is really noticeable in this project here is all these reflections. They are very expensive and they don't look good in VR, at least not in mobile VR. So we need to adjust that. But here we are ready. Let's close this. We need to restart the editor later on. So let's check our rendering settings. So here's the mobile HDR. I really want to turn this on because it looks beautiful, but let's see, maybe later. I want some MSAA and occlusion. We want occlusion culling, that's fine. We already turned this down. For normal VR, you would need forward shading, but this has no effect on mobile VR, so in this case, this is not important here. We can turn it off. Allow static lighting, of course. We could use the normal maps for static lighting, but yeah, well, okay, let's turn it on. Post-processing. We need a custom dev for our post-process outline, but also this is something that is expensive, so you may need to turn this off here. Bloom, very expensive. Ambient occlusion, very expensive. But we can bake the ambient occlusion. That's a good thing. We don't need any auto exposure here, and we really don't need any motion blur. So also turn this off. For mobile, we want to have MSAA. And this is fine. Also here, we would need this for like the Oculus or the Vive, but not for mobile VR, so we can ignore this. Go to our target hardware here and optimize project settings for mobile and scalable 3D. So you can see these are already some things we have touched here. This is disabled. They have turned off anti-aliasing. I will turn this on later. Translucency is very expensive. They have disabled it. That's good. And this is also fine for me here. So we restart our editor now. Okay, you can already see that it looks different. Most of it is because of the missing anti-aliasing. So let's turn this back on. Anti-aliasing method, MSAA. Okay, that's better. Not perfect, but better already. And we really need to rebuild the lighting. And let's go in there and let's check. Oh, this is also very important. The pre-computed visibility. There are 3 boxes in here to define the pre-computed visibility. In my opinion, they are too large. I would scale them down because we don't need it up there. The player is only down here, so we can really bring this down. Just place this where the player is really walking. And now if we build a static visibility, first of all, it tries to build the lighting, so let's cancel it. Let's do it later. But I will show you what this is doing. Show, visualize, and then there is this pre-computed visibility cells. You can see Unreal has calculated the visibility cells in order to define which object is visible from which angle. Okay, let's open up our lightness settings and see what the lighting is doing here. We have our light maps. Then scale 1 is okay. Scale bounce is turned down. We want to make sure that use ambient occlusion is turned on, and I also like to increase the occlusion component because we don't have any real-time global ambient occlusion. So I take this up to 4, and the rest seems okay. We could try to increase this, but I would say it's fine for the Oculus Quest. So let's go back to the project settings and let's make sure that under input, let's close this down. There's no default touch interface here, so clear this. There should be none in there. We need to configure our Android APK. So click configure now. Now they are writable. Make sure that we have at least 25 for the minimum SDK version. And let's make also sure that it's fine. We can remove the Oculus signature from our distribution APK. This is very important. Configure the Android manifest for development to Oculus Mobile. So make sure that this here turned on. We can also make sure that this REM64 is turned on. This gives you more CPU performance. So this is a good thing for us. The full screen should also be on already. Yeah, this is on. It's really important that your Android SDK paths are set correctly in here. So if you have done everything correctly and you go here to launch, you should see your Quest here. If not, please go back to the other tutorial, and there are a lot of great tutorials on how to do this. It's not really complicated. It's like 5 minutes to get everything up and running. But if we're here, we can go to the project launcher. And this is fine. Let's open up the advanced settings and set our data build to by the book and close this down. And if we go back to our Oculus VR, make sure support dash and composite depth is turned on. Here, especially here, the fixed forfeited rendering, you can really gain a lot of performance. So it really just renders in the middle with full resolution in the middle of the screen, and on the edges with low resolution. And there you can really gain a lot of performance. Let's set this to medium for now. But this really depends on your performance. So let's check the mobile multi-view once again, because this is a very important one. Mobile multi-view and mobile multi-view direct is both turned on, so that is good. And the rest is just performance and texture optimizing. So you can go in there under the details. Let's check what materials are in there. So we have this trim, and it's 256. So this is really not large. That's totally fine. But if we wanted to decrease it, we can set the LOD bias to something like 3. And let's see if we see any visual difference. We can set it to 4. Now you can see that we are losing some details, but yeah, but that's totally fine. So we can set it to 4. And you can do this for basically all textures being used. Also, the normal map is 512. Here you can really see a big difference, so I would keep this. But just go back into your materials and really check what is working and what is not working. And you should also make sure if we have like a material that is not reflecting, like here, like the trunk. Let's go in here. We don't really need this roughness here, so we can set it to fully rough. And this is much more performant than the other one. And also make sure you don't want to use translucent materials. Always try to not use them if you can. Better use masked materials, or full opaque is of course the best one performance-wise. So go in there and really check your shader complexity. You don't want to have any expensive shaders in here. So this is all very good. One thing I would adjust is this God rays here. And I'm going to delete them. They are also very important, and I don't need this light here. Also the water is very reflective, so let's see if we can fix this here. It's not in here, not in there. See, yeah, the roughness 0.001, that is much too low. Let's set it to 0.1. Let's see if this looks better. Okay. Of course, for the PC, I would not do this, but for the Oculus Quest, something like this looks much better. So let's keep it this way. Also, I don't need these actors here because I'm not able to see them anyway, so we can just delete them. Maybe this one we can keep. No, let's delete it. So let's check if our post-process, there are a lot of post-process in here, so we delete all 3 of them, and I just want to keep, see, maybe the global one. Let's also delete the global one and just keep the one from the framework. And now we really need to compute the visibility and the lighting because it's getting much too dark in here. But this is something I don't like in this project. They have made this lighting very inaccurate because they fixed everything with the post-process in here instead of really going in and setting the lighting right. So okay, but I think we are really good to go. If you have problems with the CPU, you may need to go in there, and a good thing you can do, for example, every actor by default has tick enabled, and he also has the tick interval set to 0. That means it really ticks every single frame, and for most objects, you don't really need this. If you need a tick, you can maybe set this to 0.1 or 0.5 or even something like 1 second. So the tick would only happen once a second, and that is much more performant than 72 times per second. So here you can gain a huge performance boost. Also, you could go in there and work with blueprint nativization. This is here, it's disabled. We also don't have a lot of logic in here. I just have the batteries and the pawns, so I don't really need it here. But I can inclusively or exclusively enable it here. And that means I can enable it for everything, or I can disable it for everything except for actors I really specify. For example, let's go in there. Let's try it out for the battery itself. I can go to my class settings, and here is my blueprint nativization. You can find it here. And let's say we want to nativize it. compile and save. And let's check, we only want exclusive only for the blueprints we selected. So this is good to go. It also, as you can see, already added it to the list of blueprint assets to nativize, so this is fine. And here you also can gain a really huge amount of performance boost for the Oculus Quest. So if you have CPU problems, just try it out. It may not work for every actor, but for a lot of them. And also here it's really dependent on your project. Okay, I think this were all the settings we needed to optimize. Let's build the lighting and the visibility. And then we are going to press the launch button and see how it looks and if everything is working on the Quest. So see you later. So our light building and our visibility building is finished. And now you can see everything works the way it should. The lighting is, as expected, a little bit dark here. So we might need to adjust this. But all in all, I think this is a good result we can work with. And one thing I have found, if you select the BP Post process and type in screen, select the post process value, there's an upsample effect with 120%. That's nice for desktop VR, but for mobile VR, let's keep it at 100 or maybe even lower if we need to. But I think we are good to go for our first Quest test. That is basically everything you need to keep in mind in order to build for the Quest. So let's select launch options and launch it directly onto the Quest. So in the next tutorial, we are going to have a look at our first Quest build. There will be some features that are not working out of the box. We will have a look at them and try to find a way on how we can further improve the quality of the project on the Quest.